All right, 36. Which could be the graph below? All right, once again, what's my vertical asymptotes? Plus or minus 1, right? X equals plus or minus 1. So what would my denominator look like? X squared minus 1, right? So we can cross this one, we can cross D out. What's my horizontal asymptote? Y equals -2, right? What would the horizontal asymptote be for B? The degrees are the same, so we go by the leading coefficients to find a horizontal asymptote, right?
+2.
It'd be +2, right? So it wouldn't be B. What about for A? It'd be -2, right? What about for C? What would the horizontal asymptote be for C?
0.
It'd be 0, y equals 0, right? So it's not that one. So it's got to be A. Questions? All right, 37. Vertical asymptotes when x equals 4, -4. What's our answer? Alright, 38. Find the x coordinate of the removable discontinuity. Alright, so let's factor. If I factor the numerator, what would that be? X minus 10, x plus 1. In the denominator, can I pull out a GCF? Can I pull out a 2, what will I have left over? X squared minus 1, right? X squared minus 1 factors into x minus 1 and x plus 1, right? So our removable discontinuity would be that part. So we have a hole or removable discontinuity when x equals -1.
Would that be +1?
We crossed out x plus the factor x plus 1, right? So we'll make that whole thing equal 0. If x was -1, right? It would be 0. -1 plus 1.
The whole thing or just
No,
that
no.
part?
Just that part.
Oh. So that's the only one you'll use to find the hole?
Whatever you can cross out. We crossed out x plus 1 and x plus 1.
So you just
That makes it a hole. And it's a hole when x equals -1. Any other questions on 38? 39. They give us a conic, x minus 2 squared over 9 minus y plus 1. And they want us to identify the asymptotes on the equation of the asymptotes. It's y minus k, whatever that y part is. So it'll be y plus 1. Slopes plus or minus.
So it's 3 over
Rise
7.
over run.
7 over
It's 7 over 3.
So whatever with the y goes on top.
That's the rise part. Yep. And then x minus 2. So it's the y numerator equals plus or minus rise over run. So it'll be what's ever underneath the y square rooted divided by whatever's underneath the x square rooted and then the x part. All right, 40. 40 is matching. All right, which one of those is a log graph? Parent functions, right? I know I haven't told you all year to have memorized your parent functions, but you need to now. C, very good. C is graph 1.
Can you explain that?
Kind of just need to commit these to memory. Seriously. It's got a vertical asymptote. The domain, the domain looks like it's from 0 to infinity, right? If you're looking at the x part, it goes from 0 to infinity. Well, if you think about log, you can't take the log of a negative number or 0. I mean, this is a parent function. You really just need to commit it to memory. Graph 2. It's the same thing as, wouldn't it be the same thing as 1 over 3 to the x power? Flip it and make it a positive exponent. So is that growth or decay?
Okay.
It's decay, right? So which one would that be?
B.
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 Wait, why isn't it D?
D looks like a reflection across the x-axis of C, doesn't it?
Yeah.
So if this is D is a graph of y equals negative log of x.
But isn't that decay too?
Nope. It might be decay shifted down. In other words, if I did minus 1 here.
Oh, okay.
But if you think about it, y is equal to this, right?
Yeah.
No matter what value I plug in for x, positive or negative, my y value will never be negative. I can't. No matter what value I plug in for x, I can't get a negative y. So it's definitely not this one. This kid's got negative y values.
Okay.
All right. I think I've kind of given this one away. Hey, very good. Exponential growth. All right, that was 40.